Hello.
Hello.
Good afternoon, everyone, and welcome to the Data Science Speaker Series at the University of San Francisco. These talks are sponsored by the Data Institute, which is the umbrella organization for all things data science and data engineering at the University of San Francisco. I am delighted to welcome you all to today's event, where we will explore the exciting intersection of data governance, AI, and innovation. We're thrilled to have with us today Mars Lan, a distinguished leader in the tech industry and the co-founder and CTO of Metaphor Data. Mars has had a remarkable career, holding pivotal roles at leading tech companies like LinkedIn and Google. At LinkedIn, he spearheaded the development of their metadata infrastructure, which played a critical role in projects like GDPR compliance, and he led to the creation and open sourcing of DataHub, a widely adopted metadata platform. Before his work at LinkedIn, Mars was a senior software engineer at Google, where he contributed to the development of Google Assistant and Google Cloud. Mars holds a PhD in computer science from UCLA, alongside degrees from the University of Auckland and Nagoya Institute of Technology. We are also pleased to have Rishi Mohan, a talented machine learning engineer at Metaphor, with us today. We also know him because Rishi is currently pursuing the data engineering concentration as part of his MSDS program here at USF. He holds a bachelor's degree in industrial engineering from the University of Illinois Urbana-Champaign, and we're super excited to have you on the other side of the table, as you were just describing here. Our discussion today will explore how generative AI is revolutionizing data governance, transforming it from a mere compliance framework into a dynamic enabler of innovation and value creation. We'll hear about how AI tools at Metaphor are automating data management, unlocking hidden insights, and fostering a data-driven culture. Additionally, Rishi will share his journey from a USF intern to machine learning engineer at Metaphor, highlighting some exciting projects and potential opportunities for some of you future Metaphor hopefuls. So, thank you all for being here. Please join me in welcoming Mars and Rishi.
Hi. Glad to come back again. I was here 2 years ago. Most of you wouldn't remember. If you do, then it's probably something wrong with you. But yeah, glad to come back here again and give another different talk from what I gave 2 years ago on, you see the long title right here. One thing I would clarify, the bio that Elizabeth just announced was written by ChatGPT, not me. So I didn't call myself a distinguished figure in technology. So.
I added that adjective. No.
All right, so yeah, I don't need to repeat what just been said. So that's me right there. All right, just to start it off by giving a little plug to our company, Metaphor. What is it? It's an early stage startup. Okay. I don't know if any of you have worked in an early stage startup, but what does that really mean? It means we're young, less than 4 years. We're small, less than 20 people. And we move very, very fast. Okay. And Rishi could probably attest to that while he was doing his practicum at our place. Learning curve is expected to be steep. Rishi, actually during your internship, learned a brand new language, TypeScript. And most importantly, I think for you guys is big impact. Okay, I've interned 3 times at 2 different big tech companies. All the work I've done in those 3 probably cannot compare to what Rishi did at Metaphor. So. We're also remote first. Started during the pandemic. Never had an office. Probably never will. We do have folks here in the Bay Area, but that's just 5 of them. So the rest is spread around the world. We try to do like in-person offsite every 3 to 6 months. So it might happen during internship. Get to meet us in real life. quickly talk about our tech stack as well, because this might be interesting, right? As I mentioned, TypeScript, we're a big TypeScript shop. So both the front end and back ends are written in TypeScript, and some of the AI stuff is also written in TypeScript as well. Luckily, we also do Python. So, Python is obviously there. Python is used extensively in integration and for obviously AI applications as well. We do development primarily in AWS. We do a lot of serverless, and we use Mongo as our main sort of storage engine. And also on the right-hand side, you're seeing a list of company logo. So on the top, these ones, basically these are, where the people working at Metaphor came from originally. Me myself work at LinkedIn, Google. We have folks work at Amazon, Facebook, you name it. And the company is also backed by some of the pretty well-known investors out there. Yep. Sorry, missed the last one. We also use, like everybody else pretty much out there using OpenAI, LangChain, and Llama Index. And we love interns. As these pictures shown here, you probably recognize Rishi right there. On the left-hand side, on the left-hand side, those four folks came from USF, the same program as you guys are now. So over 2 years, we hired 2 students each for the internship, and then one of them converted. So each one of them converted. So you converted 2 the intern into full-time. Obviously, you might have seen right here. You can guess who the other one is. We also hire obviously beyond USF, so we also work with many other interns from other pretty well-known universities. So now, what is Metaphor? This screenshot is taken directly from our website. Okay, I'll read it out to you in case you can't see it. The data catalog for every team. Okay, and a bunch of small text on it. And what does that really mean? Okay, what is the data catalog? And somewhere in there, you can probably see. So if you flip to our product page, you also see this page. Data governance. Let me see a raise of hand. How many of you here truly understand the meaning of data governance or work with data governance before? Okay, not bad. Majority of you don't, which is good because it requires some explanation. I'll let ChatGPT do the hard work. I don't expect any of you to read that right away. So some of the stuff to highlight: data quality, maybe, stewardship, ownership, compliance, security, architecture, yada, yada, yada. Pretty much. So I asked ChatGPT again. Now the answer is even my son can understand. It's like keeping your room clean, and what else is it? Like a team of superheroes making sure all the information stays in the right place and is used properly. All right. In other words, keep your metadata. Notice I use the word metadata, not data, because data is confusing. When I say keep your data clean, what does that mean? That means probably keeping your data, it's consistent, maybe. And that's what we want keep clean, so removing invalid entries and all that. That's not what the meaning here for data governance. Data governance is metadata. Keep your metadata clean. Obviously, that begs the question. What is metadata? The metadata is data about data. You got to go deeper than that. So I'm going to use my favorite example here to illustrate the importance or the meaning of metadata. In data science, it's very, very typical to find a data set in this form, which is an Excel/CSV file. Okay? Probably very familiar with this. Columns, and various columns, values. And if you're lucky, you might even have the header of the column. if you were given one of these and say, go analyze it, you look at this and say, what the hell? Right? You will start asking questions immediately. Like, first of all, who created it? It's important because I have a lot of questions to ask that person. And what does each column mean? Right? That would be naturally the very next question you want to ask. I know ID is an ID. Name is a name, even though they look like months to me. Date is a date, obviously, but what kind of date? And value, great. What does that even mean? And then you're also going to get, obviously you ask the question, well, where did the data come from in the first place, right? Was it gathered somewhere? Is it like, did someone give that to you? Or did you run a survey? Was it coming from product analytics? And also, importantly, you want to ask questions about when was this last updated? When is it valid for? Because sometimes that's very, very important. You don't want to look at outdated data. And things like, why do I have a null here? Where everything else is number, this is null. What does that mean? And in this particular example, how is this value thing calculated anyway? Right? Why is it 4? Why is it 0? Why is it 3? So all of these questions, and you probably recognize the pattern right there, it's a famous 6W. Right? All of these questions about data, and then the answer you get for those questions is data about data, which is metadata. So let's revise again. Data governance is keeping your metadata clean. What does that mean? You gotta find the answer and make sure they're accurate. If you don't do that, this piece of Excel sheet or CSV file is pretty much useless. I will quickly talk about the type of metadata that you can get. Right? We show you some examples. These are, the first thing that comes to your mind is, most of the time it's called technical metadata. Right? Talk about the structure, talk about the schema, columns, types, and whatnot. Talks about lineage, which means where did the data come from, right? Did this table get derived from another table, or is it a join of 2 tables, yada, yada. Right? Where did it come from, ultimately from the upstream, right? Did you download that data from somewhere, or is it some API that you basically crawl and get the data from? And obviously, the shape of the data, a lot of times, is super important, especially if you're data science. So these are called technical metadata. The reason why they're called technical metadata, because you can get them technically. You can go to the system, query the system, you can get those information. But in the real industry, there's also another type of metadata that's super important, which is called business metadata. All right, and this is to answer the question of why does this thing exist in the first place. A lot of time, data is the reason why we have data is to serve particular business use cases. Right? At least in the industry, that's the case. University might be different. And this is related to particular metrics you want to calculate, right? Or maybe some business term that you're thinking about. You might have to map it into the domain, the specific domain that your business is in, and so on and so forth. And a lot of times you have to tag them with specific tags and so on and so forth to really make meaning or categorize them into certain tags. So these are called business metadata. Right? And you can see this thing is not obvious. It's not something that you can just interrogate the data to get it from. Generally, someone has to go there and then annotate it or provide these sort of context around it. And then the last kind, not just business metadata, you also want to know who is using it, where is it using it, how is it being used. Right? What we call this is called the behavior metadata. Things like, hey, who owns it, right? Who is the subject matter experts of these things? What are the example queries, like useful queries I can use to query these things? Right? And then also a lot of side conversation people had about the data. These are also important metadata that you want to capture because those are important information to help you in future analysis. These are called behavior metadata. Yeah, some of these you can gather from various different systems and all that, but a lot of them also still require human intervention. And this leads to the topic of this talk. Number 2 and number 3 are hard work. Why is it hard? Because it's human. You cannot automate it easily. until you have large language model. All right, so now I'm going to hand it over to Rishi, who will talk about the work he's done in Metaphor in the context of AI, large language model, as well as the project that we intend to have this.
Thanks, Mars. I've got a little headset here. Fancy, it turned on. All right. So I'm guessing that beyond the 3 people who actually raised their hands when asked what is data governance, you still don't get it. Like, I don't get it. I work there. It's okay. It's fine. Believe me. But bear with me. So this is me. I'm Rishi. I was cohort 12. I finished the data science bit of it. Now I'm doing the data engineering part of it, which means on Mondays and Thursdays you get to see me upstairs. Hi. I worked with Metaphor as part of my practicum, which you're all maybe looking to do in the next couple months here. And as part of my practicum, I worked on some pretty cool AI features that I will briefly describe. If you have questions about those, feel free to ask me. I don't need a Q&A after the talk. I'll just touch on them. Anyway, my bio is nowhere near as impressive as Mars's GPT bio, but it exists. It's 4 lines. There it is. Thanks. Anyway, so a lot of what Mars just described is the metadata that runs Metaphor. It is technical information sourced from the actual data platforms that companies run on, which is Power BI, BigQuery, Snowflake, Looker. These are all weird names that you maybe have heard before, maybe you haven't. That's okay. They serve different purposes in the data ecosystem, and they are very valuable parts of many organizations' data sets. And each one of those collects some of that data that we just talked about, mostly technical. You have stuff like, what's the name of this table? Who uses this table? How many times is this table queried? And that's all well and good. We like that. And we bring that into the platform with Python-based crawlers. So this is the Python. I know some of you are excited here. And the crawlers are really useful because they bring that data in for us. But the trick here is garbage in, garbage out. You've all heard this term before. You know that unless you're bringing in quality information, you're not going to get quality generation out of it. That's sort of the same trend with LLM systems. If you put in crap, you get, thank you, crap. Very good. So what we also work on is bringing in more than just generic technical information. And the information that we bring in, we want to capture in a way that is genuinely useful. So beyond just how much does this query cost, we also keep track of descriptions and other text-based things about certain assets. And all of these come together in a large database that nobody could ever look at the end of the day. That's it. We put little pretty graphs and pretty dashboards in front of it, but it's still difficult to find exactly what you're looking for on a given day. And for some organizations that have, 50,000 tables, you have a lot of stuff to sift through across many, many platforms. And that's what the purpose of Metaphor is, sort of like your single plane to see what you're looking for. And the way we empower AI features, I know you love the acronym AI, you'll hear a lot. The way we power AI features is through embeddings. Embeddings are maybe the genuinely useful part of GenAI so far. Embeddings allow us to condense text data down into 1,536 dimensions of wonderful floating point numbers. And that means that we can say, I want a sandwich turns into a bunch of vectors. That's a really useful thing for us. So when we get these embeddings, we can then use them to answer questions. So if a user wants to ask something about their data, originally, you have to go find that source. Then you have to find the owner. And then maybe you Slack this guy and say, hey, can you tell me about this column? Well, the first step is to bring in that data and condense it. So you can first just go find the column. The second step is to avoid even asking the owner and say, hi, Metaphor, can you tell me about the clean bike rides data set? Metaphor says, sure, I will tell you about it. And that's what the embeddings help us do. Now, what I worked on as part of my internship was this second phase. You might recognize these logos. At the top, that's monday.com. Second is the lovely SharePoint. Then is Confluence and Notion. The one shared trend between all of these are documentation tools. And so various companies use these documentation tools to document things. And this means that they store valuable information about their data sets, who uses their data sets, what the business purpose of these data sets are, beyond just what they keep in Looker or what they keep in Snowflake. Maybe you have a document notion that says, this is who owns all of these dashboards. This is what these dashboards do. And of course, we want to fuse these things together so that when we actually ask a question, the answer is useful at the end of the day. So this begs the question, how do you get all the right data together? I'm sure some of you, many of you even, have heard of RAG, retrieval augmented generation. It's the basically de facto way of making LLMs not say crazy nonsense. And it works on the fundamental concept that LLMs need context. To get probably the right answer, you need to help it align its probability. And by doing that, we do that by doing a couple things. In the classical RAG case, a user has a question. So let's say my question is, how do we calculate revenue? Now for the really clever ones with math, you take all the things that are income and you sum them together, and then you get revenue. But otherwise, there are generally business-specific definitions for terms like this. And maybe we want our tool to say the right thing. We don't just want, go find this table and sum everything, you dummy. We want, look at this document, and this is the formula. That's what we want it to do. We want it to be a collaborator in that process. So the traditional way of doing it is we take an embedding, and we take the keywords, and we go do the search, and we get back like 100 documents, and we throw them all at the LM and say, you figure it out. Maybe they're useful, maybe they're not. Maybe I accidentally give the LM a document that says, our revenue really sucks, this is why it sucks. And that's not really probably a useful part of the answer, right? But if you know how vector embeddings work, the semantic similarity of that document is probably pretty close to the question, how do we calculate revenue? So they might be close, but they're not that useful. And so you sort of might confabulate when generating. That's classical RAG. So what we use, which is developed by, skip a bit. So what classical RAG is still really great for is it adds valuable context. In some of those 100 documents, ultimately the answer to the question, what is revenue, or how do I make a hamburger, or what are bicycles, is in that document. Somewhere in there it is. And that's useful because we want the LM to stick to the answer that we give it. We don't want it to use its hundreds of petabytes of stolen information from the internet to answer the question. We want it to use the information that we give it because that's truth. That's ground truth. That's written by somebody in the business. And we know it's true. So some of that valuable context is there, and it keeps generations grounded. It's not just nonsense. Downside, like I just said, it could also be garbage. There's no way to definitively say that a document that's about our terrible shareholder or share performance, which kind of relates to revenue, is not going to be included when you ask about revenue. And that might make it also misunderstand the question. Unfortunately, it also doesn't make cookies. I wish that RAG baked cookies, but it doesn't. So this is an interesting tool. There's an evolution of this that is introduced in RAG, where we think about involving the LM not just in summarizing, but in the actual searching for the documents. This is a trick called multifaceted filtering. So you can read more about it with this. Let's see if I can use this tool. Whoa, there it is. Yeah, right up at the top there. There's some interesting descriptions about this, but what if we, instead of just giving all the answers at the end, we gave the LM the opportunity to help us search for it. So if a user asks a question about a particular SQL query, and say, hey, what data set is this SQL query about? The user said the word data set. Why can't we just go look for data sets? And we can. So using LLMs themselves in function calling and LangChain, we can go and see that instead of just searching our entire vast database, which might include 10,000 dashboards and 100,000 documents and then 5,000 data sets, we can filter that to just data sets. The probability of getting useless generation is a lot lower. So it helps us keep the context specific. If we have very general questions about data sets, maybe we just stick to data sets because we don't really care about other information. It keeps us relevant. So of course, regular RAG does this too, but we want to focus on a certain asset type. There are some downsides with this. If you've worked with LLM systems, even if you just made an API call, you know that sitting there, you type in an answer, hit enter, and you wait. Like sometimes, if the Microsoft gods are looking down on you, your answer comes back very quickly. And it says, sorry, I can't help you with that. Very helpful. But sometimes it takes, oh boy, it takes a little bit of time to do that. And of course, that adds latency. It also adds cost to the process because we are ultimately querying the LM multiple times. But that trade-off is potentially worth the better quality answer that we get out of it. And this means that advanced RAG techniques like this can help us keep generations business relevant. With all that fun stuff though, unfortunately they still don't bake cookies. So I'm waiting on one of you to develop a company that can do that for me. I want generative cookies, please. So this is an example of what I mean. If we have a user comes up with a question, how do we calculate revenue? Or maybe another question, what is this particular database? They're too lazy to go find the actual database. And that's fine. That's why we have search engines. They're supposed to do that for us. And maybe they just want some fun help for the weekend, how to make a hamburger. It is Labor Day weekend after all. There's a couple things that happen through this process. First, we start with this question. And like I just described, the question becomes an embedding. And if you're familiar with embeddings, what we're trying to do with this embedding is find documents that are semantically similar, which is we take this nice long vector, and then we find vectors that are similar to it, and those are our associated context documents. And so in parallel to doing this nearest neighbor search, we'll also execute a keyword search. And that helps us catch cases like that second one, user ID and cost. What do you think the embedding of user ID is, that specific word? It's probably not very useful. It maybe says something about person or individual. It's not really useful, and it won't help us find a data set that specifically has user ID and cost. So catching the keyword search helps us find the right answer faster, which might also give us better context faster. So after doing those two results in parallel, we'll pass it to LangChain. LangChain is probably the most popular AI or LLM orchestration / chaining tool right now. You can develop chains where, like I mentioned before, multifaceted filtering, where you'll ask the LLM, is this document pertinent to data sets? Is it pertinent to assets? Is it pertinent to hamburgers? And it will say yes, no, yes, no, yes. So I'm looking for a hamburger data set. Very helpful. LangChain helps us do those things behind the scenes. And so bouncing back and forth with OpenAI, we'll find the exact data sets and the exact results that matter by also just asking them, are these relevant? And from there, we'll generate the right answer. Which means that we get useful things. And sometimes we get things that are not useful. Again, because of the concept of RAG, we only want it to answer questions that it knows the answer to because we gave it the answer. Of course GPT knows how to make a hamburger. Of course it does, right? I'm sure there's a billion hamburger tutorials out there. But we don't want to give it that answer unless we have the context. This is important in a business case because we want it to stay grounded. If a business has the documentation to back something up, we want to defer to that. We don't want it to use any internal knowledge. And that's why that, sorry, I can't help you with that, is the right answer here in a business case. We don't want how to make a hamburger. Unless the intern accidentally uploads a document about making hamburgers into the data system, and they're giving a demo, and they type in how to make a hamburger, and it actually answers how to make a hamburger. Fun anecdote and true.
That's true.
Oops, I didn't know that that was a go-to question. However, we now know how to make hamburgers. So at the end of the day, I think it's a success still. There's a couple extensible use cases for this. One thing that is still involved here is that as individuals, as data producers or consumers, to find this answer, you still have to go to metaphor. You can't just be sitting at your desk and reach over and wave to someone and say, hey, can you help me with this? Which is of course easier. And then in the virtual version of that, you can't just type in Slack, hey, can you help me with this? Unless, what if you could? So I wanted to briefly talk about one of the two intern projects. These are some disclosure here. They might change. They might become cooler. They probably will become cooler. So the goal here is to bring that Q&A process where a user can ask, how do we calculate revenue? How do we make hamburgers? Right to where they usually are. And that's Slack or Teams. And Metaphor already does this. If we directly mention the bot, it will say, sure, I can help you with this, and then go do its fun AI magic and come up with the right answer. But can we make that easier? Instead of you having to manually tag someone in a conversation, you have a friend here who can just give you that answer. And why can't we be an active part of that? So the goal here is to make our Slack experience more dynamic, to make it more engaging. And perhaps that means we respond to threads on its own. And in general, we want it to be easier to engage with metaphor. So here's me, totally not last night, in the DM, asking, I need help with queen bike rides. Can someone help me? My random forest model needs help. And nobody responds to me, and I'm sad. This is very sad. Sure wish someone could jump in and help me. But here, to save the day, is one of you with metaphor, coming in to save to respond to that question. And this is exactly what we're trying to do. Is metaphor is now an active collaborator. It's not someone you need to manually involve in a conversation to get the right answer. It jumps right in and helps you. And of course, you say thanks. Kudos to Metaphor Bot, I love you. So this is a pretty important thing. In general, as engineers or data scientists or data producers or consumers, context switching sucks. What I mean is you're sitting in Slack or you're sitting in VS Code or your Jupyter Notebook and you're on the move. You're locked in, you know what you're doing. And there's a hiccup where you need to figure out the answer to a very simple question. And sometimes that totally derails you. You end up going down this rabbit hole searching for things. I know it happens to me. And so that's what we're trying to solve here, is to make people more productive by getting the answer to them faster. So the second project, this is something that Mars touched on too, is documentation sucks. That's the project. I'm kidding. The goal of this is to make it so that, let me quick it up first. So this is what a table might look like when it's ingested into Metaphor. Okay, it's pulled from Snowflake, or it's pulled from some data source, and it's listed there. Somebody's created. We know nothing about it. We know it has these columns and like 9, 10 other ones. We know that it has some upstream and downstream lineage. Super useful, right? But we don't know what this data set does. We don't have that business or the social/behavioral information about it. And the goal here is to minimize work by a given user on having to fill this in. Like I said, we already have this knowledge, right? We know what the upstream asset is. When I say upstream, I mean the original table that this is sourced from. We know what that is, in theory. We know that this column means that in this table. That column means this. So why can't we make it easier to answer those questions? Now this is a similar case of RAG, right? Where we're looking to generate and suggest correct answers based off of knowledge that we have. But this is a pretty cool project because however many hundreds of thousands of these are created every year have to be documented. And that generally means you have some poor analyst clicking buttons and typing in descriptions on stuff that's already known. You already know what 5-trans sync column stands for. There's other ways to solve this, but in general, what if we can speed up that process and make it easier to answer that question so that we're reducing the cognitive load on an actual maintainer for this data set? And there's a lot of cool ways to do this, and this has a lot of exposure. There's a lot of individuals that this can affect in organizations that actually have to maintain this data. So, I don't know, do you have anything else to say on that? I forgot.
I think, being able to automate these processes is really, really helpful. Traditionally, it requires human. Think about Wikipedia, right? How many human hours you put into it to get to where it is today. But in the blink of a second, you can probably recite the whole thing extremely easily now. So you want to be able to duplicate it in Wikipedia, that should take you more than X amount of time. Same series of one.
Yeah. So the theory is that you know the information already, and you're just helping it get to the right place.
All right, that comes to the end of our presentation. No doubt you've probably been bombarded with the term AI, in this class, outside this class, in the news and all that. But I'll say it one more time. You'll be working on AI in deep learning. Thank you.
Does anyone have questions for Mars and Rishi?
Hello? First of all, thank you so much for your time, for your presentation. And I see how valuable the data quality is nowadays. my question is, how real is the removing the human element or the human time in this process? Because at the end of the day, the definitions or the explanations given by metaphor of certain columns still have to be signed off by someone, right? So where is that real? Where's that real extra value from this thing?
That's a great question. And I'll answer the question by asking another question. Do you think you yourself will be replaced by ChatGPT or something like that in the future?
I hope not.
Neither do I. So, at least in the current state of technology, I don't think we can completely get rid of the human yet. And that's our approach as well. If you notice, the AI is always playing an assistant in this game, not replacing people. So even like the auto-generated description and whatnot, we'll imagine it's a case where someone will have to basically sign up and say, hey, look, think of it as a super autocomplete thing. So you type one word and then click one button to complete everything for you. You still have to go and look at it and make sure before you click that send button.
Thank you.
Yeah, if you have questions, just feel free to come up with a mic. And one at a time.
I think this mic is disconnected, so I'll just speak loudly. I think my question might be more for Rishi, but what I'm wondering is, first, thank you so much for your talk. And next, I want to know, how do you feel about LangChain? But I really want to know how you feel. I see so much negative and so much positive, but it's kind of mixed. So I'm kind of wondering, would you recommend it to your past self?
LangChain. Hello. Hello. Oh wow.
Hello.
Okay. LangChain's great. It has some, as with any, I'm first. As with any open source tool, LangChain has its issues, but there is something to be said about how far along it is compared to a lot of its similar peers. LangChain abstracts a lot, and it makes building multi-turn. When I say multi-turn, I mean you have an internal prompt that goes to an LLM, the LLM answers that question, that feeds down to another part of the chain, so it's a back and forth. It is the most well-established multi-turn or chaining tool, and even if it is not technically the best, it has established the verbiage, the standard in monitoring, in tracing, in defining chains, and I think there is absolutely still value in learning those concepts. Ultimately, the technical implementation, you could do it by hand if you wanted to. And it would probably be pretty useful and would teach you a lot of stuff. Its abstractions are great. We use custom versions of a lot of those retrieval chains. But I would still say that it's useful to learn. It has great integrations, and the terminology lines up with what's industry practice right now. Thank you.
Is this working now?
Magic.
Perfect. Thank you guys for your time. My question revolves also a little bit around LangChain. I'm just curious, is there a good reason besides that it's quicker or I guess easier to implement that you would use LangChain rather than writing your own solutions for those problems?
I think this is like a general thing in software. Why rebuild the wheel?
So there are two reasons why we chose LangChain, and we chose it very early on. I think it was it's still probably 0 dot something, but it's early stage of 0 dot something. Yeah. So the two main reasons we chose it. One is it has a TypeScript library. Like I said, we love TypeScript, so we have a bias towards it. But more importantly is because it has these. Not just the abstraction for the back and forth part that we should talk about, but also connection to it, for example, vector database, right? Or different APIs that you have to call to sort of additionally resolve agents. But all of these things makes it very easy to move from one system to another system, so to speak, transparently, indeed, it never works out in real life, but at least it saves that part of migration. In other words, today we marry to OpenAI, tomorrow we marry to Claude. But it's very easy for us to sort of swap around those things without having to go into the code and find 20 different places you can replace. But I guess with the new LLM, you can do that with something. That's a different story. So yeah. Hopefully that answers the question.
Yeah.
It's more software engineering than anything else.
And I have another question, if that's okay. With the keyword search, is that also in a vector space, or is that just straight keyword?
It's traditional keyword search, like Google, as you mentioned. So, keyword search.
Thank you.
Still on, great. So with more quote unquote traditional machine learning, part of the thing that makes it work in production. Well, all right.
Part of the thing that makes it work in production is that you have like test cases and test metrics like mean average error and F1 score. LLMs seem kind of trickier. I don't know a lot about this. So like, how do you guys develop test cases and what kind of metrics do you use? So you're sure you're not giving bullshit to these cases?
That's an excellent question.
It's a fantastic question, yeah.
One of the poor interns you saw on the screen before worked on that. But yeah, I'll Rishi answer.
Yeah, so you're right. It is, yeah. Hello, yeah. You're right. It's very difficult to, and it's still a very in development across anybody who serves LLM applications. How do you metric it? How do you analyze that? How do you observe those things? And so our answer right now is we do it at different stages. So like Mars said, one of our interns who just finished up over the summer worked on testing the retrieval portion of this, so which is given a particular prompt, we want to make sure that these documents are consistently being retrieved. And the answer is it's a very manual process for now. It's not as abstracted as we would like it to be. There are developmental libraries that are coming around like RAGAS, which provides a framework of evaluation metrics for LLMs. Ultimately, there is no computer way to do this. You have to make an LLM call to observe what this metric is. And unfortunately, that creates a lot of cost and complexity in these testing frameworks. But for us, if we do a test every portion of that chain and test it end to end, that's pretty good for us. And it helps us monitor the model's output to make sure there's no regression. If GPT-4 Mini has a new update and it now doesn't answer questions about hamburgers anymore, that makes me sad. And so we want to keep track of that. And that's also a push that I'm working on in the next month is better observability. So the answer is it's a mixed bag. It's not as nice as it is in Meta.
But TLDR is you use another LLM to evaluate the output. Seriously. And you hope the other one's smarter than the one. Go figure.
Thanks, guys.
Yeah, I guess there's no mic, so I'll just be a little louder. Thanks for your talk. Really appreciated it. I guess one question that I had was talking about the trade-offs between retrieving queries and also having that be something that's fast and accurate. And were you guys kind of looking into options of saving queries? Like, let's say it's like a frequently asked question, and given that databases themselves, like the structure, the schemas are pretty static, even though the data itself is dynamic, I could see how there might be like repeats that you can get throughout to like kind of, have you found that there was like difficulty managing between those two things?
So I'll answer your question in different parts. So first of all, I think most of the people, at least for now, sort of accustomed to if there's an LLM involved text. Most people are okay with that so far. Obviously, as technology progresses, that expectation will line with these. So latency, as long as it's within reason, generally is not pure problem itself. So that's one thing. But of course, if you keep adding more and more complex chain, especially if they're sequential, then you cannot parallelize them, it will slow things down. It will take a while to understand. Once again, I think the technology is helping us on that front. Right? With every new model that comes out, every new API that these big companies are building, seems like the trend is going faster and faster, not the other way. So at some point, you can imagine it will probably be fast. And then, once again, from a software point of view, you want to leverage as much as possible. Right? And if the latency is not really that bad, you probably want to make sure that you invest more time in the quality of the code, maintainability of the code, rather than try to over-engineer, over-optimize on the other part. Especially you know someone else doing the hardware. So that's basically my answer. Hopefully that.
Yeah. Okay, thank you.
Good afternoon. Thank you, Mars and Rishi, for your presentation regarding the metaphor. I'm Ellen, and I have a question regarding how to deal with unstructured data in metaphor. I know for sure that a lot of data that we have are like text-based, which that for sure having LLM integrated to data search is important. However, I think a lot of data in enterprises, they are also like unstructured data. Maybe there's certain domain where they have binary data, shapefile, and my question is, does Metaphor also handle unstructured data, like to work with this metadata? If so, how is it? If not, maybe do you have like integration, I don't know, API integration capability to work with that? Thank you.
Great question. So first of all, I think we need to clarify a few terms here. Would you call CSV file unstructured?
By conventional definition, I would say CSV is structured data.
Okay.
If
What about JSON?
JSON. So the fact that it's nested and the multi-hierarchical is inconsistent, it can be unstructured data actually. It is structured, but
What about Parquet?
sorry?
What about Parquet file?
Well, with Parquet, it depends what is the source. It's like, I don't know, binary data can be Parquet, structured data can be sources Parquet, so.
Okay, sorry, didn't mean to put you on the spot. I just want to make sure that we're clear. So from our perspective, structure is very easy to understand. Table is very structured, right? Very rigid. Right? You cannot randomly add a column there. Right? If there's 10 columns, every row will have 10 columns. Right? Exactly those 10 columns. So that's structured. And the other extreme, unstructured, like you said, binary data, image data, right? Audio files, video files. That is unstructured. But the stuff I just asked you, all of those, highly nested structure, there's some schema, but not every row might comply to that schema. Sometimes no schema, you have to derive the schema yourself. Those are generally called semi-structured data. That's what most people would dump on their S3 bucket. And those things are very useful because they, you can do real analysis on it. Right? Image obviously contains a lot of information, but to retract those information, you have a huge cost associated with it. There's no assistance from one image. So we do support structure, obviously. We do support semi-structure as well. Real unstructured binary data, we don't. Right? But at the same time, there's a different class of unstructured data, which is text, as Rishi alluded to. Right? That we support through LLM. Can we support audio and images through LLM, multimodal LLM in the future? Probably. Right now, we're not getting a lot of asks from our customers. So, most of our customers are data engineers and data analysts. These folks, they don't tend to analyze these sort of data. Most of them.
Thank you.
Hi, Mars and Rishi. First off, what a great presentation. I learned a lot from Metaphor. I'm Richard, and I have one question regarding on the AI-generated column distributions. So in the past, I've used similar product called Open Metadata. I think you've heard of it. And one of the problems that we face is on how can we generate or insert column distribution when both source and destination has not enough information. So I'm posing this question on how does Metaphor tackle this problem?
So I think if you only look at whatever you have in a narrow view, for example, a table, if you're going to query a database, table, what you get is the basic schema. You get columns and type of columns. You're lucky, you're lucky. Right. That in and of itself leave you very little room to really come up with things. All you can do, think of it, right? Forget about AI. Every time when there's an AI question, I think of it as a human, can you do it? Right? As a human, you probably can't do it very well. you look at a column called user ID, of course that's user ID, what else do you want, right? But if a column names, the example I gave, value, once again, right, that is not going to be very helpful, right? I don't think as a human you can come up with any kind of description, so. But I think as a tool that we build Metaphor, Data Catalog, or Open Metadata, right, or Data Hub, which is the other open source project that we do, right? Is in a very unique position where you're gathering many sources of metadata. So through all of these things, it will help you. It will help you with more context about this data. For example, yes, just looking at the column name is probably cannot tell you much. But if I give you all the query that has run against this table, and you have the ability to read through all of them and understand all of them, would you be able to give better answer? And by you, the answer is yes. But it's going to take you 10,000 years. So, but if you feed that to LLM, it probably help you think of that. So I think there's a lot of hope. Obviously, we're not claiming that we're perfect or anything close to perfection, but I think we're moving towards that. Thank you.
See if this works. Yeah, so first off, thank you. It was great to hear about Metaphor, Rishi's experience, and learn about data governance. My question is kind of into Rishi and the work that you did. You talked about building these crawlers to ingest things from Notion and Confluence and so on. Having used Confluence in the past, I know things are often broken up in folder structures. So maybe engineering versus client services. Is there any, in your view, benefit to creating like more specialized embeddings to do ag, like for engineering or for like client services? Because I imagine the questions people are asking against engineering versus client services things are pretty distinct.
Yeah, it's a great question. So in the context specifically of like these document crawlers, right now they're sort of depending on the particular document, the document is chunk. And so if that particular chunk has an embedding that is friendly, that's probably what will come up in the results. But on a more general note, the concept of splitting up embeddings to something that's specific to technical data, something that's specific to business data or client queries or something like that, is one that we're actually looking at right now. That because a lot of these assets have really fundamental types of metadata associated with them, like purely schema-driven technical stuff, purely social or behavioral things like interaction, posts, comments, and another dimension like business descriptions and stuff. That is something we're looking at, is can we split these three up so that a single embedding is not polluted by a mix of these. And that way we have more unique information that's easier to search. So yes, absolutely. And it is interesting to see if we can extend that all the way down to the level of a document crawler. But those naturally have separate embeddings because of how a document is chunked. Like a single Confluence page might end up with 200 embeddings because of the way we chunked it. And a single document, if your document is in the engineering space, they'll definitely have separate ones. So they might not be different embedding formats, but they'll still be the same embedding engine. But the semantic content of that particular embedding will be naturally aligned with the content of it.
Cool. Okay, thank you.
Yeah. This whole chunking business is actually a field of its own almost. There's so many different methods and whatnot, and people evaluate different strategies. It's very interesting.
Thank you guys so much for your presentation. I learned a lot about data governance, so thank you. My question was, how does Metaphor data deal with users who have different clearances or access to information?
Yeah, that's a very good question. So first of all, we deal with metadata only. We never actually ingest real data, so to speak. Some of our customers are, large financial institutions and or large insurance companies and all that. So you can imagine they're very, very sensitive about sort of data security. So they're generally pretty okay with metadata, right, being made available to anyone. But it's a very natural progression from finding a table that you need to the very next logical things I want to query the table, right? So we are in the process of implementing something which is basically allow you to query the table using your own credentials. Right? So in that case, then you don't have to worry about permission. Permissioning is taken care of. So we're not going to open any sort of backdoor where we have special account that can query everything and whatnot. But rather, we just say, hey, you find the table, great. Now, you run this query, but I'm going to ask you to log into your Snowflake account or whatever account that you have. If you have access, great, here's the answer. If you don't, sorry. That's how we sort of sidestep the access control bit. That's on the direct access part. Right. But I think Metaphor tools like us has a very big role to play in terms of obtaining access. One of the big things that I worked at LinkedIn in terms of building on Data Hub is to solve this access request problem. Right? So a lot of time, it's really funny if you think about it. You find a table, and if you do not have enough information about the table, how do you know if this table is what you need? Only one way. We just go and look at the data. Right? So what ended up happening in a lot of companies, people maybe through word of mouth or through some sort of sleuthing themselves, find out, hey, there's a table that potentially is what I need, and then they file an access request, and then someone review it. And by the time they finally get access to the table 3 months later, like, this is not the table. Then they have to move on to the next one. They have to repeat this, right? So this whole access request loop is very, very manual and very, very lengthy. So if we are able to make metadata available upfront to people, at least we can cut down a big chunk of that and say, hey, yeah, this is really the one I need. Now I can go and request access. I'm okay to wait for 3 months, but I'm not okay to go back and request and wait for another 3 months. So hopefully that answers your question.
It did, thank you.
Hi. Thank you for your presentation. So kind of following up on that a little bit, I know that a lot of companies are concerned about their data and involving LLMs like Claude or ChatGPT. How do you address those concerns since you're passing that data off to a third party?
Sure. There are different spectrum of worry. So on the one side is I don't worry. We have customers who just say, love the AI, I don't care what you do. Just give me all the AI you have. And then on the other extreme, one of our customers is actually a central bank in Europe. They basically say, no AI, full stop. Not going to look at AI at all. I don't care what you do there. I don't care about the security model. We cannot possibly leak our interest rate prediction. So no, it's really means. But those are extremes. And most of the company fall in that, like what you said. They want to do some AI, but then they also want to minimize the risk. So fortunately, a lot of time, and you probably noticed from Rishi's slides, right? We did put an OpenAI logo there, but we also put Microsoft's logo next to it, Azure, because we're using the Azure version of OpenAI, not the OpenAI version of OpenAI. And you might ask, what's the difference? Actually, there's no difference, except the Azure OpenAI runs in Azure, and they have a very, very strong agreement, end user agreement saying that it will not use your data for training. And if you are Azure shop, you're already sending data to Azure and Microsoft anyway, so you don't care. Right? If you're not, then you look at the agreement and say, yeah, the legal look at the agreement, generally they say, okay, that's fine. So that's kind of how you minimize it. We did explore going the extreme of training our own large language model and run it and all that. From our perspective, right now at least, it's not cost efficient. And there's a lot of maintenance headache. And your language model is almost going to always be inferior to Claude or OpenAI. So,
thank you.
Any final question? That was.
I have a question.
There you go.
Can I see a raise of hand? How many of you think you understand data governance? I think I did a terrible job.
Excellent. Well, thank you both so much for your time and your commitment to the MSDS program. We are extraordinarily grateful, and we hope you'll stick around for a few extra minutes to answer any additional questions that the group may have. But otherwise,